Hello, this is James Black. This is for your Accelerometer lab. I wanted to show you a couple tips for how to complete the LabView portion of your lab exercise. There are a couple of things that you haven't seen before, so I want to show you how to do them. So remember, this lab is more open than the past labs. A lot of the labs I've had in the past have kind of spoon-fed exactly what you're supposed to do. This one, you need to propose how you're going to use that accelerometer, and it also wants you to come up with a means of calibrating the accelerometer, and specifically to correct for a zero offset and to apply the sensitivity. So this will vary a little bit depending on if you decide to do one axis or three axes, or how you came up with your calibration zero offset. But these basically two things I'm going to show you are universally going to be needed in your VI to complete what the lab exercise says you need to do. One last statement before I get into it. I'm not going to go over every little detail. If I don't explain how to do something well here, you need to go back and see some of those older videos. You should, the stuff that I just kind of glaze over, you should know how to do that by now. If not, go back and see those old videos and get caught up. I have my DAC Assistant here. It's a virtual instrument. I set up a USB 6009 like you're going to be using in lab. I set it up so that it's going to be putting out a sinusoidal signal from -3 to +7 volts. Let's see that that's actually what I'm getting. So I'll put waveform graph here, take my data into it, and let's run it. That's what I get, -3 to +7. Now, you're not going to see a sinusoidal signal. I mean, if you hook up an accelerometer and you are moving it up and down in a sinusoidal pattern, then yeah, you might see something like this. But for the zero offset, for that portion of the calibration process, you're likely just going to see some noise that's pretty close to zero. And that's what we want to subtract out. We're zeroing our device. I set up this sinusoidal wave with a center on 2, so we can imagine our noise is right on 2. Now you have a bunch of noise here. We want 0, so we're going to try to bring that down to 0. You may not know, like here we know that number's 2. You won't know the exact number of your offset. It's going to be something much smaller than 2, like 0.00 something. I'm just making up a number, but it's going to be small. So first, to determine what that is, back over here on your block diagram, you can right-click and go to Express and Signal Analysis. Sorry, not Signal Analysis. We want Mathematics. We want to come down here to Probability and Statistics, and we want the mean. So let's take the mean. Let's put this in here. Let's take our data and put it into that mean. And then, so up here, so look at my context help over on the right side of the screen. You see this upper node? That is the mean. If I right-click on that, come down here, create indicator, my mean should pop up here. And so so this will be fine. This is gonna, like, if this is working, this should show me my 2, which is the mean of my data. You might need something much smaller than this. You might need to go in here to display format and get yourself more significant figures. So see, that shows up there. You might your 0 offset may be way out here. So you'll need to do that, but hopefully I just run this and I get my 2. Yeah, so okay, it's 1.999211. So let's copy this and then come over here. Now let's subtract that out. So we're going to want to come here to mathematics. You can get there as more of a shortcut by coming up here to numeric. Come up here to then get subtract. Bring this down here. Now hover over this. And you see in the context help down there on the right, I have x coming in at the top, y coming in at the bottom, and the output is x minus y. So let's take our data and bring that in at x. And then, so we're going to do something a little bit different. Instead of creating an indicator, now, so the indicator, that was just showing us the output. But now we're going to create input, essentially. We're going to tell it what we want it to subtract. And that's called a control. So you right click, come down here to create, and instead of indicator, you get control. So that's there, and let's call that our offset. And then let's come over here and let's enter that in. So I copied this, I pasted that in. So it should subtract that out, and we're gonna have to move this. So let's come over here, let's delete this, let's move this down here like this, and wire those up. So now we should see this shifted down to 0. There, it did it. So we just corrected for our 0 offset. Now, the other new thing you need to do is you need to apply that sensitivity. And remember, the sensitivity is going to be the output over the input. Essentially, in this case, we're going to get a voltage as the output of our device, but that is our input in this sense. So since we're gonna want to get G's out, we're gonna want to have a sensitivity that is G's per volt, or G's per millivolt. We probably want to convert that to volts because that's what LabView is giving us as an output here. So we want to have a sensitivity that's G's per volt, and we're going to want to multiply it times the voltage so we get an output in G's. You can get that sensitivity. There is published data that you were provided with as part of the lab handout. You are encouraged to come up with a way of determining. So those, these aren't highly calibrated, expensive accelerometers. They don't come with their own calibration circuit. There's just a approximate sensitivity for all of the accelerometers, the hundreds of thousands or however many of them that they've produced. So you could use that. I would say if maybe if you're doing 3 axes, so it's a little bit harder than what some other group is doing is 1 axis, then maybe you just want to have one average sensitivity applied, and you want to use that published one for all 3 channels. Or say you're doing a 1-axis, it might be a little less challenging than what some other groups are doing. Maybe you want to make sure that you come up with a sensitivity that is specific for your particular accelerometer. And there's a link to the Arduino page that talks about how you can use gravity, Earth's gravity, to determine what that should be. I won't say a whole lot about it. That's part of what you're supposed to come up with in your proposal. Just think about if you hold your accelerometer so that its axis is perpendicular to the pull of gravity, then you should be getting roughly 0. And so that is probably where you want to determine the value that you're going to subtract out from your zero offset. And then once you do that, if you turn it so that the axis that's being measured is parallel to gravity, then you should see 1G. So you do a little bit of math with what the voltage output is at that point and come up with a number that you could either multiply. Maybe it makes the most sense to multiply, or maybe it works better in your head to divide. But you come up with a number where you put that in, and the output is going to tell you 1G. So let's at least show you how to put in that multiplication. I will say first, you might need to put in another mean here. You might want to see what your corrected mean is. So you might want to just duplicate all this and have it after that point. So you have a zeroed mean at this point. So you should, when you have it perpendicular to gravity, you see 0, and then you see some voltage when you turn it parallel to gravity that you're going to apply a sensitivity to tell you 1G. That's what we're going to do right now. It's basically the same thing as that subtraction. It's just a multiplication instead. So right click, come up here to numeric, do multiply, and put it in there. We can actually move it a little more down here. And let's get rid of this. So look in the context help, the X is on the top, the Y is on the bottom, the output is XY. So this doesn't really matter too much, I guess, where we put it. But let's do like we did before, bring the input in for X, and let's create a control, which is, we'll call it the sensitivity. So this is where we're going to apply that number we calculate from our calibration procedure we come up with, so that we convert our voltage readings to gravity, to acceleration in G's. So when you're testing this, I would say put a 1 in there. Like if you do this and you're testing this and you don't know yet, what number you need in there. So you're doing this to determine what your sensitivity should be. Make sure you put a 1 in here so you're not multiplying by 0 and just not getting anything. But just to see how this works, let's instead put in 2. So our data, our sinusoidal wave is going from 0 to 5, -5 to 0, and so on. So it's 5 volts, or 10 volts plus 5 minus 5 volts peak to peak. Let's double that. Let's run it. And there we see. So now, say if our sensitivity was 2 Gs per volt, now we're seeing 10 Gs up there at that peak where we used to be seeing 5 volts. That's how you'll apply your offset and your sensitivity. That should be enough tools for you to do those two things. So if you're feeling ambitious and you want to apply a specific sensitivity for each channel of your accelerometer, so you're going to do, your experiment is a 3-axis measurement, and you want to make sure you have a correct sensitivity for your specific device for each channel. You don't want to just apply that one generic one that's published. Express signal manipulation and split signals. Okay, you'll want to insert this somewhere back here, and so let's actually do this. Let's put this here. Let's move this over a little. Oops. So say you switch this to have 3 channels. So you have 2 more. Okay. So I'm using an older laptop right now. This takes longer than the ones you're usually using. Still wasn't too bad. So you'll want to put this in up here, and then you can manipulate each channel in a different way. So you can do probably a really similar thing for all of this for channel 1, 2, and 3. And you can also then do that same thing, express signal manipulation. You can merge them later. Say if you want to put them into your waveform chart again. Maybe you'll want to have this here. Remember, you're going to have the right to file and all that other normal stuff that you have to collect your data. Like I said, doing this for each of the 3 channels is probably ambitious. You probably just want to use the sensitivity that's published if you're doing a 3-channel experiment. If you're only doing a single channel experiment, then to kind of make up for not doing the 3-channel, you probably want to have your own calibration process, your own specific sensitivity. If you're really feeling ambitious, you could do it for all 3. That's all. I hope it goes well for you.